Hello everyone and welcome to the session, and in this session let us discuss about the OpenGL illumination functions. In the previous session we had discussed about different types of illumination models, something like ambient, the diffuse, the specular, and the different types of light sources. And in this session we will discuss about the OpenGL function which we can make use whenever I want to bring in those surfaces and the light source properties. And in this sense, now whenever going to talk about a light source or the light source property and its function, this is the function which we are going to use, the GLLight, and which takes three parameters. I will just tell you what this three parameters is going to be all about. But now first understand what this star is going to stand. If you remember, when I'm talking about the GLWart, the GLWart star, which can be replaced with a 2 character or a 3 character and so on. So similar to that, so now this star can be replaced with F if I am going to pass the floating point values, or I if I am passing with integer values, and I am going to have FV or I am going to have IV. That is, V stands for vector, where the third parameter is going to be of an array reference. If I am passing an array as a third parameter, this should be vector. If I am just passing a value, a single value, this should be the function. That's where we are going to make use of star and replace star with. And now if I am going to have the first parameter is going to be the light name or the source which I am going to use, and your OpenGL is going to give you 8 light sources. The first source is going to be light GL_light 0, 1, 2, 3 until 7. Hence there is going to be 8 light sources at a time. If you want, you can make use of all these 8 light sources, or if you don't want these 8 light sources, you can make use of any one. You can make use of any one or any of this at a time. You can make use. And so I'm just going to say GLLight, and I'm going to say GLLight 0. I'm using the first light source. In some graphics package there are more than 8 light sources, but at the basic level there's going to be only 8. This is what the first parameter is going to be. Now the second parameter. In the second parameter, I am going to pass a position. If I want, I can position a light wherever I want in the scene, and I can choose what color the light is going to emit, or I can see what is the intensity the light is going to emit, or what type of intensity the light is going to emit, or even I can bring in the concept of, or I can make the light source to be a spotlight. Hence the second parameter will make you to use any of this property by passing an appropriate parameter which is going to be available as a constant. You can make use. Now for example, if I want to set the position of a light source, I am going to pass the parameter as a constant GL position. And if I want to set the color, I can make use of GL_ambient, GL_diffuse, and GL_specular. And what all these three is, I have discussed in the previous session. And when I talk about the intensity attenuation, I am going to have constant attenuation, or the linear attenuation, or the quadratic attenuation. And if I talk about spotlight, I am going to have GL spot direction, GL spot cutoff, where exactly the spot should be broken out, and the GL spot exponent. And as the distance moves, the spotlight will exponentially grow. Is it clear? And so now I am going to have, in total, I am going to have 10 symbolic constants which you can make use. You can make use of appropriate as the parameter for the second parameter. And next, when you talk about the property value, we are just going to have this property value as a value I can pass if I am not going to use V over here. If I am using V over here, then it should be an array of the size 4, or in some cases the array size can be 3 also. So there is no restriction, the array size should be 4, but so the 4 value is usually what we use. And now if I am using GL position, should I pass a value or should I pass an array? Yes, if we talk about a position, it's about the x-axis value, y-axis value and the z-axis value, a point in your 3-dimensional coordinate system. Hence I am going to have a point, so which is going to be a position. Hence I should talk about array now. Hence we are going to have a size of 4. The first one is going to be the x value of the position, y value of position and z value of a position, and this fourth parameter is going to be the distance value. Sorry, I think I made a mistake over here, so please make the correction. The correction should be this is array of 0, this is array of 1, array of 2 and this is array of 3, because it's array of 4, hence I should be able to have 4 values over here. And now this fourth value will tell me what is the distance of the light, whether the light is going to be at an infinite distance, which will make it just as a directional light, and whether the light is going to be a local light in the scene, which is going to make me a point source or the local light source. Hence, depending upon what d value you're going to give, it is going to define the type of the light. And so with this, if I want to give a color, I'll be using it as an ambient or diffuse or specular, and so where I'm going to have RGB. Again, this should be array of 1, array of 2, array of 3 and this should be array of 4. Hence I'm going to have RGB, and A is going to be the alpha value which works on the transparent, or which is going to work on the transparency of an object surface. So which we will see it later, but right now it's often not important, but you need to pass a value for this. And so the first three values are RGB, which is going to define the color of a light. And so for the other properties, we're going to pass it as a value. That is for the other properties something like the GL constant attenuation, the linear attenuation, the spot direction, the cutoff, the exponent, all this we are going to pass the single value for this. But whereas if I want to have a GL spot direction, I may make use of the array value also as a parameter for the function. Hence we are going to have GLLight FV. Just an example function, what I can call, I'm going to have position, I'm going to have 4 values now. That is 2 in the x-axis, 0 in the y-axis, 3 in the z-axis, and 1 will make this light to be a distant light. I just want only the direction light, and so I'm giving this as 1, and I'm using the light name as GLLight 1. I'm using the second light source, and the second parameter is I want to set a position, hence I'm using GL position, and I'm going to pass the position where the light should be displayed or should be positioned. And if I'm going to talk about another example of the same function, now I'm using 0 over here. Now the light becomes a local light. It is not a distant light. Now it's going to be a point light source for us, and I'm going to tell which light source. Again the position. Now pass this as an array as a parameter for the third parameter. Now just observe, I am passing array as the third parameter, and so I am using FV, and I am using FV over here. And the next example is the color what I can give. As to give the color, I am going to have color 1. So 0, 0, 0. So it is going to set the black color. And I am going to have 1. So it is going to make the source to be a distant source again. And I am going to have color 2, all or 1. And this is going to be color white. And this is going to be non-distant light and a point source. And I am going to have color 2. I'm going to set this only for the red color, and it's going to be a distant light over here. Hence I'm going to use GLLight FV because the third parameter is going to be an array. As for the light 3, I am setting the ambient. For the same light 3, I am setting diffuse also, and for the same light source I'm setting the as specular with the different color what I have been just defined. This is how we are going to use. and the GLLight 0, whatever, if I'm going to use the first light source, and if I don't use is any of this function, by default it's going to be of black color, and for the ambient it's going to be black color by default. For the diffuse and specular it's going to be white by default only for GLLight 0. For any other light source, all the ambient, diffuse, specular will be of a black default color, whereas for light 0 only, by default the ambient is black, diffuse and specular by default are white. This is what you need to understand a few information. When I talk about again the GLLight source, and if I want any intensity attenuation, I am going to pass this as parameter. I am passing the value as 1.5, 0.7 pi or 0.4. Now if you just observe, I am passing values here, not an array, and so I am using only f. There is no v over in the function over here. And if I want the spotlight, I am just going to give the direction for the spotlight with only 3 parameters or 3 values now. And I'm going to set what is the GL spot direction is going to be through this vector or a array, and I'm going to have GL spot cutoff at what degree and GL spot exponent at what exponential value. This is how we are going to make use of GLLight source, and so I'm going to have this API, so which is going to give me. And whenever we are going to have light source in your OpenGL program, before you can make use of this functions effect in your program, you need to enable the lightning effect. If you don't enable this, none of this function execution will show its effect. And first of all, you need to enable the GL lightning in your program, and along with this you need to enable a light source. If you want to use the light 0, you need to enable this, or if you want to use light 6, you need to enable this. Hence, as an example, I am just going to have GL enable can be activate any of this light source available. If I say light 3, now light 3 will be activated, and I am just going to attain, or I'm just going to set the property of using any of the property what I've just discussed previously. Hence, as an example, by just having GL enable GL lightning and GL enable GL light 0, now you will be able to have a light effect in your scene, as well as you have a light source where you can assign some properties on this. So this is how the light source is going to work, the first step. The second step is the illumination. The surface should be defined with its property. For that we are going to use GLMaterialStar, and I'm going to again have the same 3 parameters what I discussed with the GLLight Star. Hence I'm going to have surface, and the second parameter, third parameter, we'll see what it is. But this star again replaced with f, I or fv and iv. If I'm passing the third parameter as such, similar to GLLight fv. And now in this, the first parameter is going to the surface to which the property you're going to assign. Is it only for the front face or the back face, or both front and the back face? You can choose the property what right now I'm setting to which face I am going to apply. And the second parameter is going to be whether the surface is going to emit any light. You're going to use it as GL emission. If it's going to be an ambient surface, is it going to be a diffuse surface to scatter the light, or is it going to be a specular surface to scatter only a single ray of light? And we are going to, if I want both, I am going to have GL ambient and GL diffuse, and even I can talk about GL shininess on the surface. And so this property is going to be either a array or a value what I discussed with the GLLight fe function. And so I'm just going to define an array, so which is going to be of GL float emission as 0.8, 0.8, 0.8 and 1, the 4 values of any of the choice what I'm going to make. And for the front face, I'm going to set the GL emission, and this is the set of value which should be applied as a property for the surface as GL emission. and I'm going to have the diffuse coefficient, I'm going to have secular coefficient. Hence I'm just going to bring in GLMaterialFE. So for both the faces, front and the back, apply ambient and diffuse by the diffuse coefficient, passing it as parameter now. So similarly I'm going to have GL specular for both the face with the secular coefficient, and for shininess for both the faces I'm going to give what is the shiny value is going to be. Now this is how we are going to make use of the surface illumination functions to set the property of the light, to set the property of surface or the material. Now this is what you need to understand with the illumination function. And with this, in the earlier sessions when I was discussing about 3D viewing and its pipeline, I have just spoken about the visibility detection function, the back face and the front face. What should I do with the back face and what should I do with the front face? And even we spoken about the depth buffer, the Z buffer algorithm, how exactly this is going to work. And we are going to arrange the surfaces. The depth buffer will be filled with the maximum value 1 and the frame buffer with the background color. And we are going to take each surface at a time now and compute the distance of the surface from the center of projection or from the view plane. And depending upon this distance, if the new distance what I have obtained, if it is less than the depth buffer what I have been already stored, then I'm going to update the Z buffer. Hence we are going to use less than content over here. So hence when I want to talk about visibility detection, this is how it is going to work. So if you want to understand clearly what I am stressing out here, you just need to look into my earlier sessions on 3D viewing as well as the visibility detection in 3D. Fine. So now with this, there are few functions which I can talk about when I'm going to apply the visibility detection function. The first one is the surface removal. Fine. So now whenever I'm going to detect a back face, should I remove the back face? Should I eliminate the back face? If you want to eliminate the back face which is not visible at all, if you want to eliminate, we are going to enable GL cull face. We are going to enable the GL cull face, only then you can think about elimination. If you're not enabling the GL cull face, then you will be not able to eliminate any back face or the front face from the scene. And so first you should do this. Later on you're going to say GL cull face surface. Now this surface can be anything. The front face, the back face, or the GL front and the back. Now if I say GL front as the parameter, the front face will be eliminated, will be removed from the scene. If the parameter is GL back, the back face will be eliminated. And if it is GL front and back, both the faces or the entire polygon is eliminated. And if I want to stop the process of surface removal, I am going to use GL disable with GL cull face. So it's going to disable this. And if I am going to talk about depth buffer, the algorithm which I just shown at the abstract in the previous slide. So if I want to bring in the depth buffer, the two buffers, because I'm using frame buffer, I'm using depth buffer. If I want to activate a depth buffer, then in the main function using GLUT init display mode, I need to enable this as the GLUT double buffer, or I'm going to enable it as GLUT depth buffer, and it's going to be RGB. I need to enable the depth buffer. Once you're going to make sure you are insetting the program that you need to have a depth buffer, we are going to clear the depth buffer now. We need to clear the previous content, whatever the depth buffer is going to be, using GL clear. And once you're going to activate a depth buffer, you need to activate the depth buffer algorithm. If we want to activate a depth buffer algorithm, we need to use GL enable, GL depth test. And if you want to deactivate the Z buffer algorithm, GL disable. And when I'm going to set the depth buffer, in the previous slide I just shown, we are going to initialize with the value 1. That's the maximum value. If you want to change that maximum value, you can use GLClearDepth and you can say what is the new depth value you're going to give. And the GL depth range is going to start from 0, the near, and the far is going to be 1 by default. If you want to change this range either from 10 to 20 or 0 to 100 or 0.5 to 0.75, you can make use of GL depth range. And we are going to have GL depth function which is going to tell me what test condition should I use. I'll just come to this function later. I hope you can give maximum depth, whatever the value you're going to give maximum depth. Now this will be applied, or this will be initialized with the depth buffer initially. If you don't use this, by default it is 1. And the depth range, by default it is 0 to 1. If you want, you can change this. And when I say GL depth function test condition in the array, when I'm discussing, if the new z value is less than the available z value in the depth buffer, I need to update. Hence, the condition I was using is less than. If you want to change this condition in the z buffer algorithm, which is by default less than, then you can pass the parameter. So GL depth function should use what type of condition. So by default it is less than. If you want to change this, it's going to be greater than or equal, not equal, lesser than or equal, greater than or equal, or should never compare. You are going to never compare. Whichever the surface will be available, randomly we are going to pick. We'll never compare this value. Or should I always compare? Without comparison, should I not consider the front and the back face? That is what GL always is going to be. And now this is going to be set of functions which we are going to use when we are going to talk about visibility functions. And this is all for this session. Thank you.